How many calories does 50 good form push-ups burn? This is a far more complex question than you probably think it is. I recently had some concerns about the entire calorie system. This may be a bit of a deeper answer than you're looking for. On its surface, it depends on a lot of factors. How much do you weigh? How long are your arms? This is essential to know, since the amount of work you're performing depends on how much weight you're moving and how far. How is your weight situated? When you do a push-up, you're basically turning your body into a lever where your feet act as the fulcrum. The closer to the fulcrum your center of gravity is, the less force it takes to actually move the lever. 1. How fit are you doing push-ups right now? If you can do more than 50 push-ups without breaking a sweat, it will play a huge factor in how the calories are calculated. If 50 push-ups is difficult for you, it will also play a huge factor. How are calories burned through activity calculated? When your body performs any activity, chemical reactions are set off all over the place. The most basic form of energy your body uses is adenosine triphosphate, ATP. For it to be used, the last group of atoms, with the P, the last phosphate group, is shorn off. This releases a lot of energy, a lot of wasted heat, and some byproducts like the adenosine diphosphate, ADP, and inorganic phosphate. One of the first ways people calculated calories burned was by actually measuring the temperature radiated off the body. After your body burns the ATP it has in its body, it needs to create more. This is a process that is constantly occurring within your body. Most of the energy your body uses is created aerobically, by using oxygen, using the citric acid cycle. Your body takes glucose, fatty acids, and or amino acids, reduces them down to acid sugars and then puts those sugars through the citric acid cycle. A single glucose molecule can lead to 32 ATP molecules. Fats contain nearly twice as much energy as glucose. The primary byproducts of the citric acid cycle are water and carbon dioxide. By measuring the amount of oxygen inhaled and carbon dioxide exhaled, scientists discovered that they could just as accurately measure caloric expenditures this way. By measuring the contents of the air you breathe, or the heat you radiate, scientists could calculate how many calories you were burning aerobically. Several studies over the years have compiled a list of different activities and how many calories each burns based on intensity. This list is what all of those calorie calculators online use to base their calculations off of. These numbers are vague and not even idealized. They can vary from person to person based on the particular way they do an activity to how trained they are in that particular activity. That list is found here. Compendium of Physical Activities. Classification of energy costs of human physical activities. But there's a slight problem. For many activities you perform, high-intensity activities like lifting weights and sprinting, carbon dioxide isn't a byproduct. During high-intensity muscles contractions, your cells are deprived of oxygen for a time. When your muscle cells can't get oxygen, they have a backup plan, an aerobic metabolism too. They can turn glucose, and only glucose, into 2 ATP, generating a number of metabolites, most notably pyruvate and hydrogen ions. The pyruvate is combined with hydrogen ions to create lactate in your muscle cells. Extra hydrogen ions will interfere your nerves, creating the burning pump feeling that you get during extended bouts of intense activity. When blood flow is returned to the muscle, the lactate is flushed from your cells as oxygen and nutrients are added. One of the reasons hypertrophy is an adaptation is to make this flushing process more efficient, among other benefits. Measuring the carbon dioxide exhaled during resistance training activities is futile during the activity because most of the energy required doesn't come from aerobic respiration. Recently, attempts to measure caloric expenditures by taking blood samples to measure lactate in your system after a lifting activity has shown promise. Additionally, part of anaerobic metabolism is what your body does with the byproducts. The Cori cycle is the process where your liver takes the lactate flushed from your muscles and converts it back into glucose at a cost of 6 ATP. Anaerobic exercise is very inefficient, burning calories with the activity, and in the recovery. Additionally, another effect of anaerobic exercise is excess post-exercise oxygen consumption, EPOC, where your body takes on extra oxygen and burns more calories after an anaerobic workout to repair and replace what was used during the exercise. What does this mean for push-ups? All of that taken into account, doing 50 push-ups, depending on your body weight, won't burn that many calories, 10 at the most. You might burn an extra calorie from the EPOC. However, those calories you burn, unless you're able to do a weighted push-up of 3 times your body weight, based on 60% of your body weight used in a push-up, and the fact that you will use anaerobic metabolism for activities greater than 20% of your 1 RM, will come from anaerobic metabolism, making the energy acquired at least 16 times less efficient than normal calories. This means that through those 8 to 10 calories you're potentially burning the equivalent of nearly 128 to 160 calories burned aerobically. I say potentially, because we can't be sure how much energy is being created anaerobically and how much is created aerobically. You are breathing all the time, and in between reps the blood is allowed to flow, so some oxygen may be able to get to the cells for oxidizing glucose and fat. Confusing, right? Don't even get me started on how food calories consumed are calculated. See my blog post here. A calorie isn't always a calorie by Bart Lows for more information and additional sources for this answer. Footnotes 1. Bart Lows' answer to how much body weight is used on a push-up. 2. Fermentation.